Okay. I think we're recording. 1, 2, 3, 4. Okay, yep. So here were your sort of back of the envelope multipliers. So what do you think is happening?
So what we saw in total, for to go from one element to the next in this first one, it was just sort of a simple pattern. We were dividing by 1, then dividing by 2, then dividing by 3, then dividing by 4.
Mm-hmm.
But you're dividing by the same things here, but this time going from one number to the next, you also have to multiply by 2.
Okay.
So however many times you're expecting to see the event in a year, you have to multiply by that.
Yeah. So I guess I'll just zoom out a little bit. So if we're going to fill in the 5 one, what do you think it would look like if we represented the first number by 1?
So you go from 1 to the next one, you divide by 1, multiply by 5.
Okay.
So go to 5, divide by 2, multiply by 5, get to 25 halves. And then multiply by 5 divided by 3, you get to 125 sixth. And then 625 over 36. Yeah. Or no, 24. 625 over 24. Doing the same thing.
24. Yeah. So it looks like there's a really interesting pattern here that appears to be showing up, and maybe tomorrow we can test this hypothesis and see if we get it.
All right. So basically, expecting it x times in a year, and then looking at the nth element year, you have n to the x over the nth triangular number, is it?
It's not the triangular number.
Or the factorials. N factorial.
Right. So you have, if you expect lambda in a year, you get lambda to the n over n factorial, and then times the 0 term, however many you expect.
Which, we just assumed to be 1, but it's different.
Yeah. So we'll have to figure out what that number is also.
Yep.
Okay. Good job, man.